Hi guys, welcome to GCSE Solutions channel. This channel is all about solving calculations on GCSE topics. This is our first video and our topic today is on kinetic energy stores. Kinetic energy is the energy in a moving object or in a moving body. As we can see from the picture of a man running, the energy he possesses at this time is called kinetic energy. Calculations on kinetic energy stores usually come in three forms. The first case is the substitution, where you have your question and all you need to do is to fix in your values directly into the kinetic energy formula. The second case is the unit conversion. In this case, you need to change from one unit to another. For instance, you're given your mass in gram and you're required to change it to kilogram before you solve. And the last case is the change of subject. So all of these three cases are what we will consider in the lesson. To calculate the amount of energy in the kinetic energy store of a body or of an object, we use the formula E subscript K is equals to half times M times V times V, which is the same thing as half mv squared. So this is the formula for calculating the kinetic energy, where m is the mass, m is the mass of the body of the object, and usually is measured in kg, in kilogram. So take note, when you are giving your mass in gram, you need to change it to kilogram. And then the v is the speed of the body. It's usually measured in meter per second. This is the basic formula that we will be working with in this lesson. The case 1, how much kinetic energy does a 30 kg dog have in its energy store when it runs at 4 meter per second? The mass of the dog is 30 kg. The speed is 4 meter per second. So we use speed and velocity interchangeably. So we are asked to find the amount of energy in its kinetic energy store. So that is E subscript K is equals to, you recall the formula for kinetic energy is half mv squared. And I said that it's the same thing as writing half times m times v times v times v. Okay, so we are just going to substitute those values straight into the equation. So we have half times m, m is the 30, we have the v is 4, and then we have 4 again. So 2 here, 1, divide by this, we have 2, and then when we multiply, we have 240 joules. You remember that I said that kinetic energy is measured in joules. So the dog has 240 joules of kinetic energy in its energy store. Okay, so for case 2, a 3.5 gram ball traveling at 50 meter per second. What is the amount of energy in its kinetic energy store? So from here, we are just going to see that We've been given M, which is the mass, in grams, 3.5 grams. Recall I said that whenever you are given the mass in grams, you need to change it to kilogram. So we need to change that to kilogram, and 1000 grams make 1 kilogram. So we divide this by 1000 to change it to kilogram. 3.5 divided by 1000 would give us 0.0035 kilogram. V, which is the speed, as 50 meter per second, and we are asked to find the kinetic energy. Recall our formula for kinetic energy, which is half mv squared. So if we fix in our values, we have half times m is 0.0035, and the v squared is the 50 times 50. So when we multiply all of this together, we have 4.375 joules. And approximately, we can take that to 4.4 joules. So the number of decimal or significant figure you leave your answer depends on the instruction you're given in the question. So in this case now, we've left our answer in the 2 significant figure, and we can also say to 1 decimal place, which is the 4.4 joules. The last case is the change of subject or formula. So you will always be given your kinetic energy in joules plus the mass, or kinetic energy and the speed. So for case 1, you will be given kinetic energy and the speed. So you are not given the mass. So when mass is not given, this is the formula you use. You have E subscript K is equals to half mv squared. So we want to make m the subject of formula. We have 2 E subscript K is equals to half mv is equals to mv squared. Sorry, we have 2 E subscript K over v squared, and this is what we need to apply whenever we are given the kinetic energy value and then we are given v, which is the speed. Second case where we have the kinetic energy and m, so it's similar. We need to find v. So you recall half mv squared, and then we have, it's the same process, multiply both sides by 2, and then we make v, in this case, the subject of the formula. So we have 2 e subscript k over m. Finding square root of both sides, we have the square root of 2 e subscript k over m. And this is the formula we are going to apply whenever we are asked to find the speed. We have a rope with 2.8 times 10 raised to power 4 joules of energy. Take note, joules. That means we are given kinetic, the value of the kinetic energy in the store. And it travels at 14 meter per second. Take note of the unit, meter per second. And that's the unit of the speed. So we are asked to find the mass of the rope. E subscript K is 2.8 times 10 raised to power 4 joules. And we are given the speed, which is 14 meters per second. We are asked to find the mass. Is equals to 2 E subscript K over V squared. So all we need to do is to put in our values. 2 times E subscript K is 2.8 times 10 raised to power 4 joules. Everything all over V times V. I hope you know that V times V is the same thing as V squared and is different from 2V. So by the time we multiply this, we have 285.714 kilogram because it's mass. Mass is in kilogram. So if we approximate this, we have 285.70 kilogram. This is to 2 decimal places. Now we have come to the end of this lesson. If this video has been helpful to you, don't forget to like, share, and subscribe to this channel. If you have a topic you would like us to teach on this channel, to leave the comment in the comment section below. Our next topic is going to be on potential energy store. See you then.